equations. Now we'll start solving frames. We're going to start solving frames. If you look at this frame A, B, C, A, B, C, there's two things. Sway or non-sway. And frame, go on sway or non-sway. Or side sway is allowed or not allowed. If you look at this one, can this frame under lateral load, go to the right?
No.
It's restrained by this pin and it cannot go to the right, cannot sway to the right. So side sway is prohibited, or not allowed. But if we have this one roller, so this one can move to the right, so there will be a sway, so the frame will be a sway frame, or side sway is allowed. If this is the case, if this moves, what's happening to this one? It will move. So you will have psi in span AB, or remember AB. There will be one more unknown in span AB, psi. In this case, psi or psi. And this joint stays here, and this joint stays here. Hey, you don't. If you connect them, there is no sway, no psi. As this one, same. This one stays on this line, and this one stays on this line. So there is no psi for this member, BC. Even if this one goes to the right, no psi for this member. There is psi for this member only. Good? So this one, a non-sway frame. Non-sway frame. Next lecture, I will solve the same when we have roller, just to show you what's happening to the reactions and movement. Good? So EI constant. EI constant for the column. This is, we call this one column, and this is beam or girder. Beam and girder. Look at this span. Is it an end span? End span with far end fixed. So we have two equations, MAB and BA. Theta A is 0. We have theta B. We don't know. So theta B is unknown. MAB is unknown. MBA is unknown. Two equations, three unknowns. If you look at this span, end span with far end pin. So we have one equation. You can have two equations, by the way. You can apply the two equations. You can say MBA, MBC, and MCB. But MCB, you put it in the equation 0. You can use it if you want to calculate one of the thetas, theta C. Good? So what's the fixed end moment in this span? Fixed end moment is like you fix it. And you look from inside. Fixed end moment. How much? 0. No loads. If there is no loads on the span, no fixed end moment. How about this load? Don't worry about it at this time. The effect of this load, تأثير هذا اللود راح يكون بالreactions. The effect of this load will be on the reactions. Okay? But this load is at the joint, not only on the member. مش نص الممبر, it's at the joint. So when you fix both ends of the beam, no load, so the fixed moment is 0. How about the fixed moment here? If I fix this one here, there is a load. Again, so when we write the equations, theta A 0, psi A B 0, fixed end moment at A and at B in this span, 0. Good? Let's write. So MAB equal to 2EI over L. Theta A is 0, we said, right? So they're just theta B, psi is 0, fixed end moment is 0. Good. MBA 2EI, put L directly, guys. L is 4. 2EI over 4. So 2EI over 4, 2 theta B. 2 theta B. So that's 2 theta B plus theta A 0, psi 0, fixed end moment in span BA at B 0. Good. So two equations, 3 unknowns, MAB, MBA, and theta B. Now let's go to this one. Let's go to this one. MBC equal 3EI over L, right? 3EI over L, and L is 6. Theta B, no side, right? Plus the fixed in moment in span BC at B. If you use the equation with 3 theta, you just fix one end here. So you go to the table. When you have this and load in the middle B, how much the fixed in moment here? P L
over 16.
So the fixed in moment will be like this. This is your case. If we fix this one, this is your case. Good? If this is the case, our P is 120. So we have 3 times 120 times 6 over 16. You get the answer. 135, and we know this is counterclockwise. By the way, again, everything clockwise over. Let's apply. So M BC equal 3EI, again, don't put 4 over 6. Theta B, right? Plus the fixed in moment in span BC at B, how much? Just calculate. Minus 135. How many unknowns? One more unknown. Theta B, we count. One more. So 4 unknowns, 3 equations. We have the compatibility at B. We have MBA plus MBC equals 0. Again, if we do it again for you, then I will repeat. So that's one number and that's one number. This is what we are calculating. This is MBC from the equations. If it's positive, this here, MBC, it means this way, clockwise. And MBA, right? And this is your joint. Joint B. This is your joint B. This length is 0, very small length. And this length is 0. So if this is the case here, this is how it goes here. If this is the case here, this is how it goes. So see, sum of both of them, this plus this equals 0. Sum of them won't here equal to 0. This plus this, there is a load by the way. There is a load. But sum of them won't here equal to 0. And there is shear. This length is 0. So this MBC plus MBA equals 0. That's our fourth equation. MBC plus MBA equal 0. That's our fourth equation. It means those equal 0. The sum of those equals 0. The one they start with the same letter. اللي بيبدوا نفس الحرف. مجموعهم صفر. This plus this. Okay. So 3 plus 4. Yes, if we add those. We add those. So theta B, there is 1. There is 1 theta B, right? 4 over 4, 1. And there is half. Right? 1.5 EI theta B add minus 135 equal 0. So theta B equal 135 or 115. How much? 90. Exactly. 90. 90 over 3i. By the way, the rotation, if the dimensions are compatible, the answer is in radian. No, that radians. 2 minutes. خلاص.
دكتور معلش
جاي.
لو كان هناك ان بي في مومنت خارجيه يعني
وين؟
عند بي
هون؟
حط المومنت لما اعمل فيكس كيف اعمل؟
If the moment here, the fix here doesn't affect the answer. ما بيأثر. لأن it's fixing the beam.
يعني معادلتي زي ما هي.
زي it's the same effect as this one. It will affect the reactions. يأثر على reactions. Good. I said 3. And if it's positive, it means clockwise.
الدكتور سؤال سريع إذا كان في مومنت هناك بفرق الحساب الجانبية كمان خارجية بفرق الحساب
That's true.
على مجموعهم بكون
This equation will be MBC plus MBA plus the moment in the direction equals 0. But it doesn't transfer. شو يعني ما تخبط. If it's applied here, it means applied at the joint. There's a difference between the joint and the member. When we fix, we did not fix the joint. We fixed the member. So nothing transferred. We fixed the member. Nothing transferred. Now when you write the compatibility, you will have this, he's saying. If it's like this. Then this plus this minus this equals 0. Good. Now, direct. Look, the EI will cancel. نص هاي. يعني مش بتكالكوليت الطلب. This is half. Half 90. 45. Kilonewton meter. This one, 90. 4/4. 90. State a B. EI cancel. So it's 90. This one should be minus 90. Don't put that. minus 90 tell us. This is your checkpoint. If these are wrong, this is what we'll check it. We'll discover the mistake. ضيع عليك السؤال. Just check it. So half 45 another. So it's minus 90. Kilonewton meter. Good. Now you calculated the end moments. Now you calculated the end moments. Okay. So there is a loading here of 1 ton. We calculated MBC. MBC. How much? MBC minus 90 means 90. Don't put minus 90. It's 90 in this direction. This minus means it's counterclockwise. That's what does it mean. Counterclockwise. Okay, so we have shear we need to calculate and we have a reaction here we need to calculate. Right? This is B and this is C. So we have a shear here and the reaction. We'll see. For now, if you take sum of the moment here equal to 0, to find CY. Which is, again, this times 6, it's counter. This is counter, right? So 120 times 3 minus 90 divided by 6 gives you this. How much?
60.
This is counter. This is 160. This is counter. It will be 120 times 3 minus 90
45
divided by 6. 45 up. If this is 45, this is 120 minus 45. 75. 75 up. Good? How much the axial? We don't know. We don't know. Let's look at this one. Let's look at this one. Wait, before we do this. So MAB, what is MAB? Clockwise. 45. MBA, 90, clockwise, right? And that's 90. There is shear. Make it nice. This is A. And the moment here at A is 45. So clockwise. 45. So there is a shear here, and there is a shear here, and there is an axial, and there is an axial. For your information, the axial in the column is the shear in the beam. The shear in the beam is the column is the axial. Let's wait for now. Let's find the shear. Remember what I told you? The shear, sum of the moments over the length. مجموع المومنتس على الطول. If there is no loading here, so the moments are in the same direction. So 135, 90 plus 45, 135 over the length. So look, this is clockwise couple. So this one should give you counterclockwise couple. This is clockwise. Those shear, they will be equal, but opposite to give you a couple. Right? So this must be down. If you take the moment here, this will give you counterclockwise moment. So this will be 135 over 4, which is 33.75. And this one is 33.75. Good? So you mean now, look, this is this way. And this is this way. Now, how much the axial in the beam? Very good. Very good. This is the key. Now look, this is how you do it. You do this. So how much? Wait. How much this one? 33.7. So it will be. This is left. This will be right, right? 33.75. Did we calculate this? No. Right? We did not. And what do we have in the joint? We have 60 and we have 100. Good? So, how much this one? 75 up. So this one? 75 down. So if this is 75 and this is 100 down and 75 down, how much this one? 175. So if this is 175 down, how much the axial force in the column? Good? Now, not done. So how much this one here? This is 60 and this is 33. So this one will be 93.75 and this is this. It's very important. اللي بيفهمش هاي الشغلات يا جماعه مرة تعلم ستراكشر، اللي بيفهم هاي الشغلات الستراكشر بتصير زي ما يشرب كاسة قهوة مع بسكوت زي ما بقول الصوت. تستمتع.
بس في مجال تعيد من عند ال 75 كيف يجي.
طيب تعرفوا شو اللي صار هون؟ حدا بيعرف يحكي لي شو اللي صار هون؟ Do you know what happened? ها؟ What happened?
Summation on the joint. كانت اللود على الجوينت وتوزعوا على الممبرز.
هيك واحد يحكي لي غير هيك خليني اعطيه علامة اللي ما جابش 25. When you see something like this, هاي نظرية easy يا جماعة easy. If you are standing directly and there is a column under your foot في عمود تحت إجرك, all of your load goes directly there. The full 100 went directly as an axial in the column. راحت كلها على الكولوم. مش ضفنا 100 كانت 75. ضفنا 100 صارت 175. All of it goes directly to the column. Nothing transferred to the beam. And look at this 60. All went to this number. يعني this beam is like a column for this lateral force. زي عمود للhorizontal. All of it went directly. You just added it. صح؟ It's supposed to be 33 و 60. For those, the full 100 goes here. The full 60 goes here. Then the difference زي ما حسبناها. Like what we calculated. Good? Now, let's draw. في ناس منكم بيحبوا some they like drawing on this. some they like drawing on the full. Whatever you like. Whatever you like. اللي بتحبه. جالسون فيها على طريقتين. I will draw it both ways. Okay, this is axle in kilonewton. Axle in kilonewton. How much axial force we have in this number? This is A, B, C. How much axial force we have in this number? Axial force. 175 compression. So this is 175. Is there any change? يعني هل في axial force هون؟ هو اللي بتيجي axial force هون. يجوز يكون هذا حامل مغلق. المغلق بتجيب هون وهيك ان شاء الله. There might be. But in this case, nothing. No axial force. So constant. So this one, there is constant axial force of 175 negative or compression. You can put C or negative. It means compression. Good? So this diagram, this line is for this member. Done. خلصنا. Done from this. Now let's draw a diagram for this member. What's the axial? 93. Compression, right? So we go down 93.75. 75, no change. Sure. This is axial, not shear. Axial force diagram is the easiest. Good. Now let's talk about the shear. A, B, C. The shear here. You stand from inside and you look. Negative. Shear يا جماعة both ends it has to create clockwise coming. يعني إذا هنا positive بدهم يكونوا بلفوا اثنين مع بعض على اتجاه عقارب الساعة. They go clockwise. هذا positive. Even if you look at this way. هذا positive. This is positive. This is positive. They go clockwise. So this one goes counterclockwise at the end. You compare with this one. So this is negative shear. So you go down how much? 33.75. Is there a change in the shear from here to here? Is there a distributed load here? Nothing. So constant all the way. Okay? Negative, very important. Because negative shear means negative moment. Negative change in the moment. Here, this is your shear in BC. So 75 up, positive on the left, positive. So you go up. Up. 75. As we go from here to the middle, no change. Then at the 120, there is drop of 120. 120 minus 75, 45. No change. So there is negative shear, there is positive shear. Okay? The moment. This is B, shear diagram and kilonewton. Draw for me the M, G and kilonewton. A, B, C.
بس A B كان 4 صح؟
A, B 4 و B, C 6. B, C 6. You finish? You finish? Yeah. Okay, so how much the moment at A? Positive? Positive. Okay. Positive. So we go 45. As we go from here to here, there is a change, negative shear. The area under this, 33.75 times 4, which is 135 minus 45. We go to 9. This is constant, this is linear. 9. Look, immediately. Negative 9, right? If someone goes 90 here, 0. The same. At this joint, the moment is the same. Negative 90 is negative 90. This is conceptual in structural analysis. The moment at this joint, either in the column, or in the beam is the same. Or at the joint, negative 90, negative 90. So right away, you close your eyes, you go 90. Down. And here, common mistake, classical mistake. People, you just go up. And look at it. It's negative. It must be negative. If you, لو شفت هاي positive, it means what you did here is wrong. The same. And negative, you go down. Now the change from here to here, what is the shear diagram? Is the area under the shear diagram 93.75 times.
رسم تحتها.
Sorry. So 75, 175, right? What's this? 75 times 3. Positive. What's the area? 225, right? 225 minus 90. You go in the hand here, 135. And this is constant, so this is linear. Then this should be minus 135. 45 times 3, you go to 0. So that's your moment there. Positive, negative. Positive, negative. And you should, when you draw the wrong diagram, we should find these distances. You have to put on the diagram these distances. So the designer knows when the moment will change from positive to negative for the reinforcement. Okay? Which is easy, similar triangles. Easy, similar triangles. This distance will be 45 divided by, where's the slope? 33.75. We'll get this distance from here to here. Similar triangles. Good. Correct this one and give it the right and front. سلموا. Give me the clues. أعطيه اللي جنبك واسحبه لقدام. ماشي. 49. أو 50. Yeah, give it and give it to the point. Good. Okay. Next time, and before, no, stay. For next lecture, I want you to find for me what's the fixed in moment when you have concentrated moment on the span. We have concentrated M at distance A or B. How much the fixed in moment and what are the directions? Good? We have both ends fixed. Or when you have one end fixed. You fix one end, what's the fixed in moment here? If you fix both ends, what's the fixed in moment? Due to a moment along the span. Good? I'll Google anywhere. You make sure you find those and you bring them with you to the class. جيبهم معك. يا ويلي ما بجيبهم. This, I want the fixed moment. When you have a span, عندك span, عندها concentrated moment and then a depth or at any location A, here, what's the fixed moment? Okay? And we have just one fixed. Huh? قول له أنا والله أنت لك. قول لك 10 دقائق. Copy them. وجيبهم. حتى لو صورت مع التليفون ما عندي مشكلة. You make sure you have them, you bring them to the class. Okay, let's do this then. We'll finish it next time. Same problem. Now this one is roller. This one is roller. We had how much here? 60 and 100 and 120. And this one is 60, 6 meters. And the column is 4 meters. Example. New example. This is the same as the previous example, except this support now is roller. It means the frame is sway. Sway frame. A, B, C. So the deformed shape will look like this. This is delta. This is delta. So the sway of delta. Same as this one. Same as this one. Why? Because the length of the column almost stays, so the length of the beam stays the same. Stays the same. Okay? Almost. So this is, there will be a side. Side span AB. Side and span AB. So if you write the equations, MAB equal 2EI over 4 2 theta, theta B, right? Minus 3 psi. Minus 3 psi. Fixed in moment is 0. 1. And BA equal 2EI over 4 2 theta B minus 3 psi. Fixed in moment is 0. And BC 3EI over 6 theta B, no sign, plus the fixed in moment in span BC at B, we calculated this to be 135. So minus 135. unknowns now? Side. So how many equations we have? 3. How many unknowns? 5. So we have one, we know. M 4. I still have one. I need one more equation. I need one. What?
MCB.
Which one? MCB? We'll add theta C here. If you do MCB, you will have theta C. You add one unknown, one equation, not so easy. Where you get the equation in a sway frame? It's tricky. In a sway frame, where you get the fifth equation or the equation you need is tricky. Again. I will show you, but just look at this.
Deflection.
Just look at this. Again, look at this also. That's a sway frame. By the way, sway can be from lateral load or from vertical load that's unsymmetric. Not in the middle. If it's symmetric in the middle, no sway. If it's unsymmetric, this will move. And you will have a sway. This rigid stays 90 degrees. Or the same as the original angle. Rigid. If it's this way, you rotate, they go together. Same rotation. Okay? If it's 90 degrees, stays 90 degrees after the deformed shape. Anyway, what do we have in here? If you count, all of them are interior span or end span far end fixed. We have this. We have MAB, MBA, MBC, MCB, MCD, MBC. So we have 6 equations, right? Each segment have 6 equations. Have 2 equations. So we have 6 equations. What are the unknowns? 6 moments. 6 moments, right? 2 thetas, A and 1 side. So how many equations we have? 6 equations. 2 compatibility, MBA plus MBC equals 0, MCB plus MCD equals 0, that's 8. We still need 1 equation to get side. We still need 1 equation to get side. Where do we get the equation from? The delta is unknown.
deflection شو اسمه؟ ساين deflection على
Delta is not given. This delta is different than the beams. It's different than the beams. This is you need to calculate it. So it's unknown. شو معروف؟ Delta is unknown. يعني you can say delta over L. Delta is unknown. يعني either يعني delta or sine is same guys. Delta or sine is same. Delta over L is sine. Delta is unknown or sine is unknown. Where do we get them from? This is you do it from the 3-by diagram or the structural problem. Look at this now. Now, see what you are calculating. Good? What's this? What? And this? And this? And this? What? Now.
عندي يصير معادلة MAB.
Okay, look. tail equal to 0. But MAB plus MBA. If you this is up, right? Plus VA times 4, which is 60, equal 0. Some of them في shear here and the axial axis. Some of them will equal to 0. This is clock in the signs. Clock in the signs. Shear here is to the left. It means the reaction is also to the left. A reaction or shear. This plus this times 4 equals 0. That's your sixth equation. M AB plus M BA plus 60 times 4 equal. That's your fifth. The second part, remember when I draw this? Remember when I draw this? This is VA, right? And this one is V whatever. D. VA plus VD equal the load. VA equal MA plus MB over the length. This one equal MC plus M this over the D. So you have 4 moments in this one over length. You see where you get the fifth equation? The shear. From the shear. It's known. That's a new equation. What's this? Yeah. MAB plus MBA. We never continuity, this is not continuity. Plus the shear times the length equal 0. Or you can say MBA over the length plus MBA over the length plus the shear equals 0. That's your fifth equation. So when you have sway, we have to use this equation. We have to get advantage from this equation. Good? Easy. Now, just follow the, you have a second. Now next time I will not solve this one. Solve it for yourself. I will solve one like this one.